Hey there again. This is the second part of Dart Basic Programming Language tutorial. And in this video, I'll be teaching you about control flow and functions. So let's begin. You can think of control flow statement as a way for the program to run differently according to the state and condition of the program itself. You'll understand what I mean once I show you some examples. So firstly, we'll look at if and else statement. So how that works is type if some condition occurs, do something here. So let's say if let's create a variable is happy equal true. And we can call this variable using the variable name is happy. If this condition evaluates to true, which is a boolean, you can print I am happy. So what this means is if this variable evaluates to true, run whatever is in between these two brackets. So when we run this, it is gonna print I am happy. So let's turn this variable into a false. And if you run this, nothing is gonna happen because once it reaches this part, is happy will evaluate to false. So if you run this, it is gonna say nothing because it will never reach this point. So if else has another way to catch in case this part of the code is not run, you can do it by printing writing else here, and you can print something like I am not happy. So what happens here is if you run this code, it's gonna print I am not happy because if this variable is false, it is gonna come here and look for the else, and it's gonna go inside this loop. So if you run, it's gonna print I am not happy. And if we change this to true and we run this, it's gonna say I am happy. So this is if else. So there's a small extension for this as well. We can put another statement here. Let's call it is tall, for example, true. So we can put another statement, we can check for another statement here by writing if else, and you can continue this forever by typing more if else and checking more conditions. But let's just keep it simple and only put one if else here. So if else comes between if and else. So if you do this, you can put another thing to check, which is tall. And we can do something here, which is print I am happy, and we can print I am not happy because if this is evaluated to true, it's gonna come here and it won't go through here. So if I print this and print I don't know what I am doing here. So if we do this, it's gonna always result to I am happy because the condition is always true here. So it's always gonna come here. So once it reaches here, it will forego everything here and not even check for anything below. So if we write some statement here, say program ended, it's going to say I am happy and it's going to print this statement out. As you can see, that's what happens. So let's change this to false, for example. So the Dart compiler is smart enough to know that it's never gonna come to this part. So it says, try removing this code. Let's just ignore this. And if we run this code, it's gonna come to this, between this scope. So if you run this, it's gonna say, I'm not happy because this is false. So it skips this part and goes here and checks. And this is tall variable is true. So it's gonna come here and it's gonna skip this part. So let's keep this as false as well. So what is gonna happen is, if this condition is false and this condition is false as well, it's gonna come to the else statement and print this. Let's try to do this. And yeah, it's working. So that is if statements. Before we look into another control flow, I can show you something called expression operation as well. So we can check, we can inverse this by writing an exclamation mark in front of this variable, which is a boolean. So what this means is just the inverse of is happy. So if I want to look for a false value here, or let's say if is happy is true, and I want this statement to run when is happy is false, we can do that by putting an exclamation mark, which is inverse of this variable. So if we write print I am not happy, it's not gonna run because is happy is true and we are looking for the inverse of this true, which happens to be false. So if we run this, nothing's gonna happen, and we can type program ended. So if you run this, only this is gonna print out because this is looking for the inverse of is happy true. So this is looking for if is happy is false, then it's gonna come here. So if you run this, only this is gonna run. Yes. So instead, if we, let's clear this, were to keep this as false, this is gonna run because if is happy is false, it's gonna run I'm not happy. So let's try this, and that is true. Another operator you can use is equality operator. So instead of using boolean, let's try to create a string name 1, for example. Let's create messy and check if the value is same. Name 1 equal. So if you want to check whether two values are same, you can do it by typing two equal signs. Let's just put messy, then we can print they are the same. So if we print this, it is gonna say they are the same. Like I said before, anything in programming is case sensitive. So if we write this, it is not going to print out something. So to make it clearer, we can put a else statement here, and let's type they are different. So what happens is we've created a variable name 1 and give it a value of messy with a capital M, and we're checking here if name 1 is the same, has the same value as whatever we have given here, which is a messy with a capital M. So if we try to run this, it is going to come to else, which is a print statement that says they are different. Let's try it with capital M. Yeah, they are the same. Another one you can use is the inverse, which means exclamation mark and an equal sign. So what this means is, if name1, the variable, is not equal to this string here, it is going to run this line. But if name1 is equal to this string here, it's going to come to here. So if you run this program, they are different. So this is how you evaluate if this value and this value here is not the same. Let's look at another operator called logical OR operator. So let's create two Boolean variables. Is football player equal to is playing for Barcelona. Go true. So let's write a logical operator which works by taking two booleans, and this is how you write OR operator. Two pipe signs, and you can give another sorry, this should be this variable. Let's copy that, paste it here. So what this checks for is, if this is true or this is true, it will come to this line of code. And we can put an else statement here and say print is not a football player or is playing for Barcelona. And let's put here is either a football player or is playing for Barcelona. So when we write this code, it's gonna initialize the variables first, and it's gonna check here if is football player is true, then it's gonna come here. Even this, let's for now just try to run this code. It's gonna say it's either a football player or is playing for Barcelona, because one of this is true, and if we're checking if one of this is true, then run through this code here, and it's gonna skip this part. Let's make one of them false. So what happens is, once it gets to line 5, it's gonna check if this variable is true. For now it's false, so it's gonna skip over, and it's gonna check if this is true. And once it sees that this variable is true, it's gonna come to this curly braces. So this statement is gonna run. So let's try that. Yeah, it's either a football player or is playing for Barcelona. So this is true. Let's try to make this false as well. So once we do this, it's already showing that this is not gonna work because both are false. So what happens is, it checks if this is football player and this is playing for Barcelona, and since both are false, it's never got this will never evaluate to the function will never evaluate to true. So it's always gonna come to the else statement down here. So if you run this, this should print out, and it prints out. So this is OR logical operators. So let's move on to another control flow, which is a for loop. So what is a for loop? A for loop is a way for us to loop through some iteration of list, or you can give a range of number. For now, let me just explain by writing the syntax for loop. For firstly, I'll be explaining for loops for a range of numbers. So the syntax is for, let's just give it int I equal, we initialize a variable int I to be 0, and we have to give a condition I less than. This is how you create less than. For more than, you can use the sign. Let's just create less than. If I is less than, let's say, a given number 5, a semicolon, what do we want to do is we create the post increment operator on the I. So what this means is start the index at I equals 0 and do some operation here between the curly braces until I reaches a value less than 5. So, and after every time this part of the code is ran, it is gonna increment by 1. So let's try to print the value of I once we run this code. So to make things clear, let's print start of the program to be here, and let's print the end of the program. So once we write this code, we're gonna print the start of the program and print the end of the program, and something is gonna happen in between these two print statements. So let's see what happens. As you can see, it prints out 0, 1, 2, 3, 4 because we are looping through the values between 0 and the 5 index, and it's gonna print out the index I every time it loops through. So the code between line number 4 and line number 6 is being repeated, is being looped through. So the value of I changes every time it iterates because it says increase the value of I by 1 every time it increases. And you can change many factors here, such as you can increment it by plus equal 2. If you do this, it's gonna increase the value of I by 2. So if you run this, 0 to 4. So you can do something like 6, and instead of using I less than 6, you can use if I is less than or equal to 6. This is how you write less than or equal to. You will print I. So if you do this, it's gonna print 6 as well because it loops through 0 and it's incremented by 2. And every time it increments, until this condition is met, until I becomes 6, the loop is gonna keep continuing. And once it becomes 6, it's gonna come through and end at line number 8. You can do this for, you can decrease the value also. So it's the variable I will start off at 0, and the condition is that do not stop the loop until I is less than or equal to 6. And we are telling it every time the loop ends, you have to decrease the value of I by 2 and print the value I, then decrease the value of I by 2. So if we run this, what is going to happen is it's going to keep, let's just see first, it's going to run forever. So to stop this, what you can do is just head over here and press the stop button. So okay guys, I crashed my computer because it ran forever. So this is why you have to be careful. So what happened was, we set the value of I to be 0 and we set a condition that will never be met. So it keeps on decrementing the value of I. So it's gonna be stuck in this loop forever. So you can't do something like this because this condition will never be met. So we have seen how to use for loops for a range. Let's try to use for loops for a list, which is gonna be more fun. Let's create a list of string. Let's give it names. Let's fill this list with some names. Okay, so we have a list of string in names, and let's use a for loop for this list of string. So how you do that is for string, since we've given it as string, you can use var as well. For var name, okay, for now just keep name in names. Notice I've used s here and a singular term for name. What we can do is do some operation for every iteration of the element inside names. So every time the loop runs, we are referring to the element in the names using this variable called name. So if we were to print something like print the individual element in each iteration of the loop, we can do that by saying print name. We are referencing each iteration of the element by giving it the variable name. So if we run this, it says Ronaldo is greater than Messi. Moving on, instead of doing that, let's give the variable a type, string type, which is also correct here. You can't do something like int because names contains list of string, so that is false. So instead, let's do string. And why you want to do this is because you can access the functions and everything of name down below if you specify the data type here. And also you can keep this variable as anything, because this variable name only exists in this scope between these two curly braces. So if you were to write print n, it's gonna work because n is created only for this loop. But if you were to say print n below the loop, below the scope, it's not going to find n because this only exists between these two curly braces. So that is one thing about the syntax of for loops inside list of strings. Sorry. Another thing you can do, or let's do another example. Let's just create a list of int. Let's just do 23, 21, 12, 21, 54. What you can do is you can do any operation between these two brackets. So this is not working because it says names is a list of int. So let's create this as int. For now, let's just make this x, and let's name these numbers. Instead of printing the value inside each of these, let's try to do something like increment the value of each element. So what we can do is x plus plus. So what happens is it's loop through all these values and increment the value by 1. So if we were to print this, what happens is all the value will be incremented by 1 if I'm not wrong. Okay, something went wrong. Let's try to do this instead. X plus 1. Why this does not increment is because I made a foolish mistake, but x is only available in this scope, so it will never change the value because x only exists in this scope. So instead, if we want to do something like that, why not we add it into another list? Let's just create a variable edited list well, let's make it an empty list. Instead of putting that there, we send the x value into the list, empty list here, by saying print x. And if we print this instead of the numbers list, it should work, if I'm not wrong. Yes, so it works here. So this is for loops for list. And one example I would like to give is what happens if we don't specify the type of list. So this is why it's always good practice to give the data type of a list. So what happens here is we can't know for sure if x will be an integer type, and you can't add for, let's say there's a string here somehow. So what happens is this should actually throw an error, or even if it's not an error, there should be a problem in logic. If we run this, yeah, so this is the problem of not giving the data type to a list. So what happens is we are trying, once it gets to this element, we are trying to do a arithmetic operator on a string. So this kind of problem arises if you don't give data types. So if you were to give it a data type, this is create if you want to do any sort of arithmetic operation on a list, the whole list has to be int. Okay, so you have to remove this, and this should finally work. Okay, it works. So let's move on to another control type, which is called a do and a while. So let's talk about while loops. This is how you write a while loop. True. While this condition is true, do whatever is inside this bracket until this condition becomes false. So if I were to write hello world here, and if I were to run this, let's just say print program has ended. If I were to run this, this will keep printing hello world here until the computer crashes again. So I'm not going to be doing that. So what happens is this will print forever. So instead of doing this, we have to give some logic that won't crash. So let's just say count. We create a variable called count. Let's just keep it 0. What we want to do is, while, let's create a condition here such that it's not an infinite loop. While count is less than or equal to 20, do something here. So while count is less than 20, what we want to do is increment every time the loop completes by 1. So if we do this, and let's just print the count before it increments. So what we should expect is it should print out the count and increase the value by 1 and keep looping until this condition is met. So let's try to do that. Yeah, once it reaches 20, it has ended. But if I were to do something like this, it's gonna crash again because it's gonna run into, it's gonna keep doing this until infinity. So let's not do that. This is while, and there's another variation of the while loop, which is do while. Let's print hi while some condition. So for that, let's say count less than, okay, let's try bigger than 2. Okay, this will not work. What am I doing? While count is less than 2, print high. So every time what we want to do is increase the counter by 1 as well. So what happens is the count will increase every time in the loop, and this loop will keep running until the count is less than 2. So what is the difference between do while and only the while statement? So a do while will evaluate the condition after the loop, meaning after this has been done, then only it will check this condition, whereas a while loop will check the condition and complete the loop. So let's try to do this. It says it does it 2 times because this happens first, then it will check after the do statement is done. So let's look at breaking and continuing. For simplicity's sake, let's create another while loop. While and while count, sorry, let me get my syntax right. While count is less than or equal to 20, and let's write some if statement. If count equal 5, what we want to do here is break, for example. So let's print the index count every time it increases, and let's increment the count as well. So let's see what happens if we add a break statement. So the loop is broken once this condition is met. This also works for for loops as well, and it works for all types of loops. And let's see what happens if we use the continue instead. So let's put this up here instead. So what happens is a continue will break only the internal loop. So if we do this, this will not work because it's going to run into infinity, because a continue will skip anything below this loop and move on into the loop. And since every time it checks at the start of the loop, it's always going to result in going to this continue. Let's make it clearer by putting the parenthesis, the curly brackets, and bringing this up. So what happens is once the loop reaches 5, it's always going to stay 5 because it does not give the loop an opportunity to increase the counter, because every time it reaches here, once the loop reaches to count 5, it will continue and move on, and in the next iteration it will check if the count is 5, and since there's no way for it to increase the counter, it's gonna keep continuing until the program crashes. So instead of doing that, let's put the counter here and increase the count before we check for the count variable. And instead of doing 20, let's just do 10 for now to make it simpler. And if we were to run this, you can see when it reaches count 5, it will not print the count, because once the count reaches 5, it goes through this continue and it will break this iteration of the loop and skip to the next one. So the print function, anything below this line of code is not run, because it says continue to the next iteration of the loop. So that is the use of continue and break. Now let's move on to switch case. Let me create a new variable, string variable, and let's give it a variable name of planet and give it Pluto. So the syntax for switch statement is, first you gotta write switch, and you have to check for something, planet, and we are evaluating the variable planet here, and do something if the case of this evaluation results in whatever we put in this case. So let's say if the case is that the planet variable is equal to Earth, the string, then what we want to do is do something here. Do something. For this case, let's just do a print Earth. And you always have to end these cases with a break. If not, it's gonna run forever. So let's create another case. If it's Mars, what we have to do here is print Mars, and we have to break it again. And for this type of cases, you have to give a default value as well. Which is, let me see, what do we want to print is I am no planet. So as of now, we can't really, this line will never reach, sorry, defult. Okay, now it works. So what happens here is we have created a variable planet with the value Pluto, and once it reaches line 4, it will check for whatever is inside the planet variable. And in the case that the value is equal to Earth, it's going to print Earth. If the value is of this planet is equal to Mars, it's going to print Mars and break the switch statement. That is what the break is there for. But in case somehow there is no case where we have not made a case for something like Pluto or whatever, it will result in a default where it will do, what it will do is print I am no planet. So let's try to see what happens if we run this. It says I am no planet, because we have not created a case for when planet variable is equal to Pluto. So let's create that case Pluto. What do we do when the planet evaluates to Pluto? We print I am actually a planet, guys, and we have to break out of the switch statement. So let's try to run, and yes, this is what happens. So let's take another example. Let's just say moon. If we print this, it's gonna return to default. So this is the use of switch case control flow. Let's now look at functions and what it does. So a function is basically what you can think of it as, if you call it, it's gonna do something for you. So let's just create the basic function syntax. Let's just say shout, and you always have to give parentheses, and the function should start with small letters, it can't be capital letters. So let's just create a function shout, and you have to give this kind of bracket. So what happens is, when I want to do something like print I am shouting, instead of writing this line every time, we can call this function and let it do whatever is sitting inside these brackets instead. And let's just do something like I am screaming as well. So what happens is, whenever we call this function, it's gonna run this code every time. So what makes this useful is, you can reuse this line of code whenever you want by writing it once here. So let's do something like, let's loop, for instance, int I less than 3. Initialize it. So let's say I want to print these 2 lines 3 times. Instead of telling the machine to print 3 times like this, what you can do is, you can tell it to loop through 3 indexes and print, or not print, call the function like this. And if you run this, it's gonna print these 3 lines 3 times. So what you're doing is, you're looping through index I for 3 iterations, and you're calling the function by writing in this format, shout, and you gotta give the parenthesis. And let's say, for example, you have only 1 line of code. What you can do is shorten the function into an arrow function. So how you do that is, let me fix this. And this should be removed as well. So instead of writing that long line of code, what you can do is just call out the function like this. So it does I'm shouting. So let's look at let's create another function, get time, give it the parenthesis, and instead let's do something called return. Let's return a value for 5, and it works like this, but it's best practice to give it a data type, which is, for this case, int. So what this means is that whenever you call this function called getTime, it is going to return back a value of 5. So int is the data type of the return, which is going to be 5. So what you can do is, let's try to call the function here. If you're calling this function and if you run it, nothing is going to happen, because all you're saying is return the value 5. You're not telling it to print or anything. So let's create another variable where we'll store whatever is returned from this function. So let's declare a value called int y, and let's assign the variable y whatever value is returned by this function here. So when you assign y equals getTime, what happens is the value of y will be set to whatever is evaluated here, which is 5 for this case. So if I were to print whatever is inside y, it's gonna be 5. So this is a simple function and how return statement works. So let's look at some other thing called parameters. So this is kind of useless because all you're doing is returning 5, which is kind of useless if you look at it. Let's create a function called sum of 2. And if you read the number, if you read the variable name, it says sum of 2. So what I want to do is return the sum of two numbers. So let's say 2 plus 2, and the return type would be int as well. So this is basically useless because we are typing whatever we want here statically, meaning I can't change these values as of now. But what makes function useful is that we can pass in our own parameters. So let's say we want to create a generic function that adds the value of two numbers. So what we can do is give it a parameter type int, and let's just name the variable inside this scope of how we reference whatever we passed as x, and another variable y. And now we have access to whatever we passed to this sum of 2 function using this variable x and y. So what we want to be returning is x plus y. And if you call this function, it's gonna say, you need a variable here, parameter here, such that the function works. And let's store whatever we get from sum of 2 function into my sum equal. So this function will return the addition of the whatever we pass in x and whatever we pass in y. So let's put 5 and 3. So what happens is, if you run this code, this is going to return the sum of 5 and 3 because we passed 5 as x and 3 as y. And one more thing you can do is, instead of returning it like this, you can do additional lines of code by saying int sum is equal to x plus y. And instead of returning this in this way, you can just return the sum. But since it's a simple code, we'll just stick to using x plus y. Or you can simply create this into an arrow function and return x plus y. So if I were to print the value of my sum, it will return 8. Okay, this is just the basic of functions. Before we move on, let me explain something called named parameters. As you can see just now in the sum function, what we did was pass in x and y, and let's say you have more than that many parameters, z as well. So what happens is you have to pass in a orderly manner. So if I were to say 5, 3, and if I give 8, so 5 will always take the x will always take the value of the first parameter, y will always take the second parameter, and z will always take the third parameter, and so on and so forth. So what this means is that you have to make sure you put the numbers in order for the function to work. So instead of doing that, what we can do is give these parameters names. So let's create something else called get full name, and this will retain a string. And what we want to do is take the first name of a person and the last name of a person and return the full name. So let's see, we want how you can write a name parameter is using this parentheses, and give it type string first name and string last name, and you have to add a required tag in front. If not, you can make this nullable as well, but for now let's just make sure both are required. And what we want this function to do is return the full name by combining the first and the last name. So let's return first name plus last name. This is another way of string interpolation. And once we call this function, let's create a variable my name equal, let's call this function, and it will give you the name of the parameters here. And it wouldn't matter if you change the order of the parameters as well, because it's already named. So let's give the name Cristiano. So if I were to print my name, it's gonna return the full name. Run this. Okay, there's no spacing, but that is because we have not give spacing. That is how you use a named parameter. And there is also such thing called default values. In case you don't give the last name, what you can do is give it a default value. For now, let's give it nameless. And what happens here is, if you don't pass any last name, the last name will be defaulted to nameless. So if I were to skip the last name here, it's not going to throw any error, but if I were to print this, the default value is whatever I set it in the parameter. So this is how you give a default value. In the case of unnamed parameters, the way to give default value is use square brackets. Let's see, string first name and give a square bracket string last name, and you have to give a default value if you're inside the square bracket. So the last name is nameless as well. And if I were to call this function, it only asks for first name. So let's just give it messy, and let's hold this value inside a variable, and let's see what happens if we print the variable. So messy nameless. So if you want to give the last name as well, you can just give it on the second parameter by saying, and if you were to print it now, it's gonna type out whatever we gave it here.